meaning of continuity of a function. Now, having discussed the concept of domain, you must now know there are certain functions where some inputs will not give rise to any output. That means when there are no outputs, the function cannot be continuous there. You see, if the domain is negative infinity to positive infinity, and the range also is from negative infinity to positive infinity, the graph of the function will be continuous. There will be no break anywhere. For example, the graph of x of t equal to 2t. You can use any input, you will get an output. That means the function will be continuous, the graph will not have a break. If there is no break in the domain of a function, it is said to be continuous in its domain. That means a graph of a continuous function has no break in it. Look at the graph of, we looked at the graph of this, f of x equal to x over x plus 4. Do you remember that graph? I just showed it to you. It has a break at x equal to negative 4. That's right. In other words, we saw that as x gets closer and closer to negative 4 from the left, the output value, the function value, goes to positive infinity. As x gets closer and closer to negative 4 from the right, the output of the function goes to negative infinity. There is, we say, a break at x equal to negative 4. The function is not continuous at x equal to negative 4. Now there's a break at x equal to negative 4. How about this function? Where does it have the break? X squared over 4 over x minus 2. Is it continuous all over or on the entire number line? Well, if you notice, the denominator contains x minus 2. That means when x minus 2 equal to 0, the function has a discontinuity. It doesn't give you a meaningful output. That's right. The graph of this function is here. Now look at the graph of the function. Can you look at this and tell me if you notice something? As x gets closer and closer to 2, you can see the function comes all the way here. This is very close to 4. Now, there is a hole here, which shows that at x equal to 2, you have no output. But anything greater than 2, yes, there is output. So, there is a break in the graph at x equal to 2. That means the function is continuous everywhere except at x equal to 2. At x equal to 2, there's a break, which means x equal to 2 is not in the domain of this function. Alright, discuss the continuity of the function x minus 1 over x plus 5 times x minus 2. What can you say about the continuity of this function? Well, in order to discuss the continuity of a function, you need to find the domain. Are there any values of x that is not in the domain? Well, if you notice, when x plus 5 equal to 0, the denominator will be 0, and that cannot be allowed. That means x equal to negative 5 is not in the domain of the function. Similarly, when x minus 2 equal to 0, the denominator will be 0, and there will be no meaningful output. Or x equal to 2 is not in the domain of the function. So the domain of the function does not contain x equal to negative 5 and x equal to 2. That means the function is not continuous at these two values of x. Look at the graph of that. As the input x gets closer and closer to negative 5 from the left, I want you to pay attention to the left and right I'm using. As x gets closer and closer to negative 5 from the left, the output goes to negative infinity. as x get closer and closer to negative 5 from the right, the function output goes to positive infinity. There's a break in the graph at x equal to negative 5. Similarly, as x get closer and closer to 2 from the left, the function value goes to negative infinity. As x get closer and closer to positive 2 from the right, the output value goes to positive infinity. There is a break in the function value at x equal to 2. That means the function is not continuous at x equal to negative 5 and x equal to negative 2. There are breaks in the function at these two values. All right. We will now look at the meaning of limit of a function. What is the meaning of limit of a function? Now, I was actually telling you when the input approaches a certain output from the left and from the right, the function value actually approaches certain value. Is that right? In the case of the first, when you have the denominator x plus 4, we notice that as x approached negative 4 from the left, what happened to the function value? Well, the function value either went to positive infinity or negative infinity. Is that right? Now we will use that concept to discuss what is called the limit of a function. Now let's take the case of the first function we talked about, a of t equal to 7.5t. Now, as time gets closer and closer to 1 hour, the amount A will get closer and closer to 750. Is that right? The student can say, oh, I have finished working half an hour. That means I can now take home $3.75. Is that right? Now, as the time gets closer and closer to 1 hour, you can say the output gets closer and closer to 750. And when x equal to 1, the output will be 7.5 because at t equal to 1, the function is continuous and we exactly know at t equal to 1, the value of the output is 7.5. Similarly, as x gets closer and closer to 5 hours, the output A will get closer and closer to $37.5. Now, we are now going to express these statements mathematically. We say, in the limit when t approaches 5, the amount A will approach 37.5. As t gets closer and closer to 5 hours, the amount of dollars get closer and closer to 37.5. Now here, t can approach 5 either from the left or from the right. Well, I know approaching t from the right has no physical meaning in here. It may be difficult for you to think about it, but t approaching 5 from the left has a meaning. Is that right? 4.5 hour, 4.6 hour, 4.7 hour, 4.8, 4.9, 4.99. Yes, I'm approaching 5 and my output is approaching 3750. Well, you can also think hypothetically as t approaches 5 from the right. 5.1, 5.01, 5.001, and finally t equal to 5. It will give you the output 3750. And we write it like this. Limit t approaches 5, 7.5t is 7.5 times 5, which is 37.5. So what did we do to find the limiting value of this function? Well, all we did is replaced t with that limiting value. We wanted to find the output of the function in the limit when t approaches 5, as t gets closer and closer to 5. What all we need to do is replace t in the function by that value. Now, that this is possible only if the function is continuous, keep in mind. Similarly, what is limit x approaches negative 2 of the value of 5x minus 2? Well, what all we need to do is replace that x by negative 2. So the limiting value of 5x plus 2. Now look at the way I'm reading this. The limiting value of 5x minus 2 when x approaches negative 2 can be obtained by simply replacing x by that negative 2. That would be 5 times negative 2 minus 2 equal to negative 12. One more time. Limit t approaches 5, the limiting value of 7.5t when t approaches 5 can be found by replacing this t by 5. Limit x approaches negative 2 of this quantity can be found by replacing x by negative 2. That's right. Now here, this tells you as x get closer and closer to negative 2, y get closer and closer to negative 12, and finally when x equal to negative 2, the function output is negative 12. Now, watch this. I'm putting down this as a definition. If a function is continuous at x equal to c, you can see in both these cases, the function is continuous at t equal to 5. The function is continuous at x equal to negative 2. So what we did here is valid only if the function is continuous in that particular limiting case. Now we're going to use x equal to c. In this case c is negative 2 and in this case t equal to 5. So if the function is continuous at x equal to c, then to find the limit as x approaches c, we simply replace the x value by the c value. This is the c value here. This is the c value there. So if the function is continuous at x equal to c, then to find the limiting value of the function as x approaches c, we replace x by c in the function and find its value. That is the method of evaluating a limit when the function is continuous at the point where we find the limit. Okay, how about this? Limit x approaches pi by 2 of sine x over x. Now, is this function continuous at x equal to pi by 2? Well, how do you know? Well, if you put x equal to pi by 2, what does it give you? Sine of pi by 2 is 1. So it will be 1 over pi by 2. Yes, it is continuous. In other words, an input of x equal to pi by 2 will give you a meaningful output. So what we are doing is to find the limiting value of this function when x approaches this c. This is our c. We replace x by this c value. That will be sine of pi by 2 divided by pi by 2. And you should know that sine of pi by 2 is 1. So that will be 1 over pi by 2. That is 2 by pi. Now, this is x equal to pi by 2. As x gets closer and closer to pi by 2, the function value is 2 over pi. Now, once again, I want to emphasize here, x can approach pi by 2 from the left and also from the right, and in both these cases, the output is the same. All right? Okay. That is the point pi by 2, 2 over pi. That is, as x gets closer and closer to pi by 2, the function value gets closer and closer to 2 over pi, and ultimately when x equal to pi by 2, the output is 2 over pi. What happens